First up, let's talk about variables and block scopes. Here's one of my favorite JavaScript trick questions. Is this a valid JavaScript line of code? Testing it in the playground seems to work fine. There are no errors, which means it's valid. So now the question is, what did it do? These are nested block scopes. We could write code in here, like var v equal 42, and then access the v variable right after, and it would work fine. JavaScript does not really care about the spacing or new lines in here. A block scope is created with a pair of curly braces, just like this example here. This also applies to if statements and for statements as well. These also get their own block scopes. Block scopes are a bit different than function scopes, which are created for each function. You can see one difference when using the var keyword to define variables. Variables defined with var inside a function scope are okay. They don't leak out of that scope. If you try to access them outside of that scope, you can't. As you can see here, we cannot access the result variable that was defined inside the SumFunctions scope. However, when you define variables with var in a block scope, you can totally access them outside that scope afterward, which is a bit problematic. And here's one practical example of that. This for loop has an index variable that ticks from 1 to 10. You can access that variable inside the loop normally, but you can also access the same variable outside the loop. After all the iterations are done, the value of I here will be reported as 11, which is a bit weird. This is why the more recommended way to declare variables in modern JavaScript is by using the let keyword instead of the var keyword. When defining variables with let, we won't have this weird out-of-scope access problem. If we replace this var here with let and redo the same test and try to access I after that, you'll get the error that I is not defined. This makes sense because we're outside of the scope where it was defined. So this is much better. Block scopes, like function scopes, can also be nested, like the trick question we started with. This is a nested block scope. Within each level, the scope will protect the variables defined in it as long as we use the let keyword or the const keyword, which behaves in a good way like the let keyword. We use const when the reference assigned to a variable is meant to be a constant one. References assigned with const cannot be changed. Note how I'm saying references here and not values, because defining an object with const does not make it an immutable object. It just means constant reference to it. We can still change that object just like we can do within functions that receive objects as arguments. If the variable defined with const is a scalar one, like a string or an integer, you can think of it as an immutable object, because these scalar values in JavaScript are immutable. We can't mutate the value of a string or an integer in JavaScript. And when we use const with these scalar values, we can't change their references either. However, placing an array or object in a const is a different story. The const will guarantee that the variable is pointing to the same array or object, but the content of the array or object can still be mutated. So be careful here and keep that in mind. Variables defined with const are much better than those defined with let for scalar values and functions because you get a guarantee that the value did not accidentally change. Looking at this code example here, and assuming that between the first and last line there is a big program. On the last line, if the program runs without any errors, we can confidently say that the answer variable still holds the 42 value. For the same example with let, we would have to parse through the code to figure out if the answer variable still holds the 42 value. If you need a variable to hold a changing scalar value, like a counter for example, then using let is okay. However, for most other cases, it's probably much better for you to stick with using const for all your variables.